Welcome, and thanks for joining me once again for Math and Science for Young Children. In each of our sessions, we will be reviewing math, science, and early childhood topics. For this session, our goals are to become aware of key misunderstandings in early mathematics education, understand the importance of number sense as a fundamental math skill for young children, and apply science process skills to exploring baking soda and vinegar reactions. Make sure you download the note sheet to go along with this video and stick around as we learn all about math and science concepts for young children. We're going to take a look at 3 common myths that are associated with early mathematics. Myth number 1 is that for young children, learning mathematics is less important than the developing of early literacy and language skills. Early mathematics has a strong predictive power for later reading achievement. This finding could be explained because flexible thinking, analytical thinking, abstract thinking, and problem solving involved in mathematics broadly applies and has implications for literacy development as well. Myth number 2 is that early mathematics is primarily about learning numbers and shapes, but we've learned and will be learning more as we go along. How numbers and math, well, they're just complex. Everything involving math is complex. Numbers are complex, patterns are complex. Everything involving math is complex. This means that we're having to use higher level thinking to even do basic math. And myth number 3, teaching early mathematics is easy since we're just teaching the most basic math. When we teach math, it's not just about knowing the basic concepts. You need to have the background content knowledge as the educator. You also need to know how and what instructional methods you will use. And then you also have to know the knowledge that the children already have. And once this all comes together, you can teach young children math. Early mathematics is certainly foundational mathematics, and everything else that they will learn will build upon the basic foundations of math that they learn in the early childhood classroom. If students have those strong foundations, they're going to be able to grow stronger as they learn new concepts. Objective number 2, we are going to understand the importance of number sense as a foundational math skill for young children. Our math focus for this week is number sense. Number sense is the ability to understand the quantity of a set and the name associated with that quantity. So, for example, if I hold up 4 fingers, children must mentally connect the numeral 4 and the word 4 before it can be said that they have an adult vision of 4-ness. Number sense is a building block for all future mathematical learning. Developing number sense takes place gradually over time as children develop cognitively. It results from exploring numbers and using them in a variety of contexts and relationships. So there are 3 big ideas when it comes to mathematics and number sense. Numbers are used in many ways, and some are more mathematical than others. When you think about it, we use numbers in a variety of different ways, and it's not just for counting. And that's a lot for young children to sort out. We have referential numbers. So an example of that might be school gets out at 3:14. We have cardinal numbers. There are 314 people in the school. We also have nominal numbers. My area code is 314. And then we have ordinal numbers. I am 314th in line to buy tickets. So just think of those 4 different ways that we use numbers. And it's not just a numeral like showing up on a die, like when you roll the die and then there's a numeral. We use numbers in lots of different ways. Myth number 2, or big idea number 2. Another big idea is that quantity is an attribute of a set of objects that we use to name specific quantities. So, for example, 3 is the quality that a set of 3 apples and a set of 3 penguins have in common. To see the 3-ness of the apples, we have to set aside the redness, the shininess, the fruitiness, the roundness, any other attribute it might have. So one has to see past those qualities so that they can see the quantity of the item. And the third big idea, or the last one, is the quantity of a small collection can be intuitively perceived without counting. And this is known as subitizing. It's the ability to see a small amount of objects and know how many there are instantly without counting. This is a set of seeing a small group or a small set of objects or dots and just knowing it, okay? So the best example I know how to give you is when you roll a die, okay? You don't have to sit and count necessarily all. Let's just say you roll 5. You don't have to say 1, 2, 3, 4, 5. Okay. You don't have to count all the dots so that to know that you have 5. You just see it and know it. It's like a pattern. Children begin to learn that sometimes we don't need to count because we can subitize. It is a skill that helps them understand addition and subtraction as they get older so that they see that numbers are composed of parts as well as a whole. Okay, so it can be composed of parts like 1, 2, 3, 4, 5, or I can just see that pattern of 5 and know, ooh, that's 5, okay, as a whole. Objective number 3, apply science process skills to exploring baking soda and vinegar reactions. This exemplar activity for this session is a physical science activity with baking soda and vinegar. Children can make predictions about what will happen when they mix baking soda and vinegar together. They use an eyedropper as a tool to drop colored vinegar onto baking soda and observe the bubbles, fizzing, and color mixing. As they experiment with different amounts of vinegar and mixing the colors, they experience cause and effect relationships. The underlying science concepts that students will learn through doing this activity are: mixing baking soda and vinegar together creates bubbles. Bubbles have gases inside of them. And new colors are made when 2 or more different colors are combined. Be sure to use your exemplar activity guide to read through the engage, explore, and reflect as you complete your experiment. And after your experiment, be sure to reflect, like using questions like, well, what happened? What did you discover? To learn more about chemical and physical changes, choose one of the ideas for further exploration. So let's get a little bit of background knowledge on changes, excuse me. A physical change is a change that does not change the chemical composition, while a chemical change is when a substance combines with another to form a new substance. Physical changes are usually easily reversible since there is not a new product. And it's often only a state change, meaning that a liquid is turning to a gas or maybe a liquid turned into a solid. A chemical change, however, is usually not so easily reversible because it creates a new product. And it's often done with light, heat, sound, or fizzing, like one of those 4 things will occur. So that wraps us up for this week's episode. You can learn more about this topic by reviewing the resources posted in your Blackboard course. As always, if you have any questions, please reach out to me. I'm here to help. Thanks again for joining me, Miss Murph, as we learn all about math and science for young children. Have a great time learning, and I'll see you next week.